Okay, now so in the last lecture we talk about the Bessel ordinary differential equation, right? So why does this arise and how we can find out the solution? Then we find out the solution to the Bessel differential equation. Like if you remember, it was like x square y double prime plus x y prime, right? Plus x square minus n square y is equal to 0. So this was the Bessel differential equation, and we find out its solution. In one of the solution, since this is a Bessel differential equation of second order, so it will have two independent solutions. We find one of the solutions by the series approach, right, or by Frobenius method, and you know that we find out its solution to be Jn of x, which I represented, which is like y1 of x. So they are called as a Bessel functions of first kind. So we represent them by Jn of x. They is given by summation r running from 0 to infinity minus 1 raised to power r, Shabash, 1 divided by r factorial gamma of n plus r plus 1 x by 2 raised to power n plus 2 r. ओके, अच्छा अब बंद ही रखिए वॉल्यूम, इससे थोड़ा ये नॉइज आता है. ठीक है. So we in the last lecture we discussed these things, and we consider a Bessel differential equation, why does it arise, and then we find out its solution. I told you that the first we can find out the first solution by the Frobenius method, and why we cannot find out the second solution by, if n is non-integral value, we can find out the solution and with by the series approach. But if n is not an integer, if n is an integer, then we cannot find out the, because this term here will become a gamma function of a negative number, and as a result all few terms in this j and x will be equal to 0, and we cannot have the series approach. We cannot find the second solution by the series method or the Frobenius method. Now in today's lecture and in coming lecture, we will be discussing some properties of these Bessel functions of first kind. So first of all, the first example I'm considering today is it's an example. I will ask you, if n is a positive integer, then we have to show that, then we need to show that this j n of minus x, and if I'm taking this function along the minus negative axis, it is always given by minus 1 raised to power n jn of x. It's very easy to show because you already know what is jn of x, right? Okay, the solution will be, it's very simple. These are certain properties we will be discussing here on, some very simple properties. Like for example, you know that since we know that the solution to the Bessel differential equation, that is Bessel function of first kind, is given by Jn of x is summation r running from 0 to infinity minus 1 raised to power r 1 divided by r factorial gamma of n plus r plus 1 x by 2 raised to power n plus 2r, right? This is what we already have obtained in the last class. Now simply I will just replace this x by minus x. So Jn of minus x will be again summation some r running from 0 to infinity minus 1 raised to power r 1 by r factorial, this gamma of n plus r plus 1 and this minus x by 2 raised to power n plus twice r, right? Okay, now it's very simple. If you look at this equation, now this x by 2r, I will just write it separately here, then I will just generalize it. X by minus x by 2 raised to power n by 2r. Can I write it like minus 1 into x divided by 2 raised to power n plus 2r? लिख सकते हैं ना? Okay, so then I will write down this as minus 1 raised to power n plus 2r into x by 2 raised to power n plus twice r, right? So, and then this will be equal to, I will write down this as minus 1 raised to power n into minus 1 raised to power twice r, right? Minus 1 twice r is always positive. It will always be positive. It will be, so this will be simply equal to minus 1 raised to power n. So all these terms, so you will write down here from this you write that Jn of minus x will then be equal to summation r running from 0 to infinity minus 1 raised to power r will remain as such, and then 1 divided by r factorial gamma of n plus r plus 1, and x by 2 raised to power n plus 2r into minus 1 raised to power n. So this minus 1 raised to power n, you can write it here. You can write it minus 1 raised to power n summation r running from 0 to infinity minus 1 raised to power r 1 by r factorial gamma of n plus r plus 1 x by 2 raised to power n plus 2r. But you already know that from this particular equation that this is Jn of x. So you write down this as minus 1 raised to power n Jn of x. Just replacing x by x and x by minus x, and you will get this property. I hope it is clear. If it is clear, then I will move to your next property. The next property is we have to show that, just, is it okay? Is it okay, or I need to repeat it or some?
तो नोट नहीं कर सके सर.
I will send you the screenshots or I will send you the notes. Don't worry. मैं
ओके सर.
screenshot आपको भेज दूंगा फिर बाद में, because time भी थोड़ा कम है जैसे. You just follow the steps and you can write it later. I will send you the screenshots. I'm not robbing it. Okay. Now see, I have some another example. The another example I am taking that we need to show that j half integral of x is equal to under root of 2 by pi x sine of x. You have to show this thing. Show that this is equal to this, right? See how we will. I will just move a little slow now. As I said, since you already know that this Jn of x is equal to it's x raised power n. Just go through the previous lecture. Before writing it in the general form, I have written it like this: x raised power n, 2 raised power n, gamma of n plus 1. Where I told you that you need to replace C0 by x raised power n, 1 by 2 raised power n, gamma of n plus 1. And after that we obtained that solution जैसे मैंने अभी लिखा था. So this is Jn of x is x raised power n, 2 raised power n, gamma of n plus 1. And then we have the series like minus 1 minus x square divided by 2 raised power 2 into 1 factorial n plus 1 plus x4 divided by 2 raised power 4 into 2 factorial n plus 1 into n plus 2 plus then x raised power 6, 2 raised power 6, 3 factorial n plus 1, n plus 2, n plus 3, and so on and so forth. So we have obtained this series already while we were trying to obtain the solution of this Bessel's ordinary differential equations. Okay, so now in this particular differential equation, I will suppose if n is equal to 1 by 2. If n is equal to 1 by 2, what will this equation become? So it will become j half of x. Okay, it will be like x raised power n is 1 by 2 divided by 2 raised power n, that is 2 raised power 1 by 2, gamma of n plus 1 by 2, that is 1 by 2 plus 1. Is it okay? Into minus 1 minus now x square divided by 2 raised power 2 will remain as such, 1 factorial will remain as such, n is 1 by 2, so it will be 1 by 2 plus 1 plus, okay, plus x raised power 4 divided by 2 raised power 4 into 2 factorial is 1 by 2 plus 1 into 1 by 2 plus 2. Just इस equation में I am just substituting n is equal to 1 by 2. Okay, so now you can see that this is under root of x by 2 gamma of 3 by 2, right? I will write down this particular equation again. I will write down this as this is under root of x divided by under root of 2 gamma of 1 by 2 plus 1, that is 3 by 2 into 1 minus x square divided by 2 into 2 into this is 3 by 2 plus x raised to power 4 divided by 2 raised to power 4 into 2 into 3 by 2 into 5 by 2, right? This is 2 by 3 by 2, this is 5 by 2, plus some other terms. Okay, or I can write down this, I will just combine, I will write down simply this as under root of x by 2. This is under root of x by under root of 2. Gamma of 3 by 2 is always equal to 1 by root 2 of pi. You, because last time I told you about the gamma function. Now you also need to remember that gamma of 1 by 2 is always equal to under root of pi, and gamma of 3 by 2 is always equal to under root of pi by 2. So that value I am substituting here, that gamma of under root, sorry, this 3 by 2 is always equal to under root pi by 2. Okay, then this equation in the this will be become 1. This will be simply 2 and 2 will cancel, 3 into 2, that is 1 minus x square by 3 factorial, 3 into 2 into 1, 3 factorial plus x raised to power 4. This 2 will cancel out with, it will be 2 raised to power, that is 2 to the 4 to the 8, right? That will be 1 2 to the 4 to the 8, 2 raised to power 4, 1 2 and 1 2. X raised to power 4 divided by, it should be like 5 factorial. 1 2 will get cancelled out. 5 into 3 into, okay, yes, 4 into 2. So it will be 5. Jab 1 2 will cancel out with this 1 2, it will be cube. So it will be 5 into 3 into 4 into 2 into 1. That is my 5 factorial, minus so on some other terms, right? Okay.
Yes, sir.
Now what I will do, I will just multiply and divide this right hand side, multiply and divide by x, multiply and divide by x, multiply and divide by x. So when you will multiply and divide by x, it will be, Shavash, what will this equation, I will write here, j half of x will now be equal to this under root of x. Let me write it as such. I will write those under root of x by 2 into, this will be 2 by under root of pi, 2 by under root of pi, because 2 will go into the numerator and it will be 2 by pi into x, oh sorry, 1 by x. मैं यहाँ पे लिख लेता हूँ, आई एम जस्ट मल्टीप्लाइंग इट बाय डिनोमिनेटर. जब यहाँ पे x मल्टीप्लाई करोगे, इट विल बी x माइनस x क्यूब बाय 3 फैक्टोरियल प्लस x 5 बाय 5 फैक्टोरियल minus so on, right? Now what is under root of x divided by x? यहाँ पे this you can write this as under root 2 into under root 2. 1 2 and 2 under root 2 will get cancel out. It will be under root x into under root x. It will be 2 pi x, right? Under root 2 pi x, sorry, under root 2, 1 2 will get cancelled. It will be under root 2 by pi into x. ये x इसमें absorb हो जाएगा. So you can write down this as this equation. I will write it here. You will write this, you will simply write this as j half of x will be equal to under root of 2 by pi into x. This is like x minus x cube. Do you know what is this series? This is simply the sine series. Sine x you can expand it to the power series. So this is sine x. So this we were supposed to prove, and we proved that j half of x is equal to under root 2 by pi x sine of x. Do you got this point how I write it here? It's quite easy. Do you, or do I need to elaborate it? Is it okay for you people?
Yes, sir.
Yes,
Okay, very
sir.
good. It's quite easy. 2 और 2 आपका हो जाएगा. Then we will be write this as this. Okay, shabash. Now, so if you have understood this thing, you can similarly prove that. So this is an assignment for you. Show that similarly. Show that j minus half of x is equal to under root 2 by pi x cos of x. You have to prove it. Just prove it. This is an assignment. You can do it later. Okay. So if you have understood these things, now I will move to the next part of the lecture. That is again about this Bessel differential in this Bessel functions of first kind, and we call them as the recurrence relations. There are some 6 recurrence relations. I will show you a few, and you rest you can prove it yourself. Okay, let me just rub it. But you should prove this one, that j minus of is equal to this. Okay, fine. This is what we called as recurrence relations. Recurrence relations for Bessel functions. Recurrence relations for Bessel functions. Or Bessel's function. Now, the first of the the recurrence relation is the first one. It's we need to prove that d by dx of x raised to power n jn of x is equal to x raised to power n jn minus 1 of x, right? So jn d by dx of x raised to power n jn of x, we need to prove that this is x raised to power n jn minus 1. Yani we will lower the n value by 1. We will lower it by 1. Where we need to prove whether this is really true, or if we are going to find the derivative of a function, Bessel function of first kind, and multiply it by x raised to power n. Now again I will start with the Bessel function that we already know, since we know that this jn of x is equal to summation r running from 0 to infinity minus 1 raised to power r 1 divided by r factorial gamma of n plus r plus 1 into x by 2 raised to power n plus 2r, right? This is what we already know, that we already have obtained this solution. Now what I do, I will just find out the derivative of this. So d by dx of this x raised to power n jn of x will then be equal to, I will just multiply it by x raised to power n and then take the derivative. So you write down this as d by dx of, if you will multiply it by x raised to power n, right? So what will be, it will become इसके बाद, so let me write it clearly. I will just write it in one single setup. So it will be now d by dx of summation r running from 0 to infinity and d by dx of this and multiply it by x raised to power n. So I will write down the first few terms as such, minus 1 raised to power r into 1 divided by r factorial gamma of n plus r plus 1. Shabash. Then I will write down this separately. I will write down this as x raised to power. When I multiply it by n, it will be 2n plus 2r divided by 2 raised to power n plus 2r. इसको मैं separately लिख रहा हूँ. Okay. Now simply what I will do, I will just find out the derivative. We have to find out the derivative with respect to x. So I can, this is all constant here. So I can find out the derivative of this function. So you can write down this as, when you are going to find the derivative, you write down this simply as, you don't need to write this, summation r running from 0 to infinity minus 1 raised to power r divided by 1 divided by 2 raised to power n plus 2r को मैं पहले लिखूंगा, then r factorial into some gamma of n plus r plus 1, right? Okay, then what will be the derivative of this with respect to x? It will be 2n plus 2r into x raised to power 2n plus 2r minus 1, x raised to power n minus 1 जो आप लिखते हैं, 2n minus 1. Is it okay? Okay, now this thing I am doing it separately, then I will just write it in one single step. Now this is 2n into 2r. Can I write it like 2 into n plus r in the numerator, 2 into n plus r? So this is now in the denominator, it is 2 raised to power n plus 2r into gamma of n plus r plus 1, right? Now if you remember, I told you last time that gamma of n plus 1 is always equal to n gamma n, right? So can anybody tell me what is n plus 1, gamma of n plus r plus 1? So that means gamma of n plus r plus 1 is equal to n plus r into gamma of n plus r. Gamma of n plus r. Okay, so now using all these things, so this is now 2. 2 will go into the denominator. It will be 1 divided by 2 raised to power n plus 2 r minus 2. So I will simply write this equation as summation r running from 0 to infinity minus 1 raised to power r. 1 divided by this 2 will go into the denominator. It will be 2 raised to power n plus 2r minus 1 into r factorial. And this gamma of n plus r, I will write down this as n plus r into gamma of n plus r. Here in the numerator we have n plus r into x raised to power 2n plus 2r minus 1, right? Now this n plus r and this n plus r will get cancelled out, and we will be left with this term summation r running from 0 to infinity minus 1 raised to power r. Okay, now x raised power n, I will just take x raised power n out of it. If I'm going to write it x raised power n divided by, और यहाँ पे मैं simply r factorial divided by gamma of n plus r. Okay, now this is same, x raised power n, this will be like x by 2 raised to power n plus 2r minus 1, x raised power n plus 2r minus 1, right? Okay, now see, this thing I can write down this as some, this is okay, x raised power n is there, so I will write down this as jn of n minus 1 into x. Why? It's very similar because we have lower it the n. If I will substitute n equal to n minus 1 here, n equal to n minus 1, right? For n we have to prove it in the later on. For example, so we have जो term हमारी जो Bessel function हमारे पास है, that is this. That's this. Now, for example, I will substitute n is equal to n minus 1 in this particular differential equation, in this Bessel function. Just try to do it. Just substitute n is equal to n minus 1. So you will write down this as jn minus 1 of x. Here, jn minus will be equal to summation r running from 0 to infinity minus 1 raised to power r, shabash, 1 divided by r factorial. This will become gamma of n is equal to n minus 1. So it will be simply gamma of n plus r, gamma of n plus r into x by 2 raised power. Now n is n minus 1. So it will be n plus 2r minus 1. So that is why I write down this term as jn of n. Sometimes if you write down j is equal to n plus 1, so it will change accordingly, right? So we proved that this d by dx of x raised power n, jn of x is always equal to x raised power n j n minus 1 of x. So this was the first reconciliation we were supposed to prove, right? Is it okay? Is it okay? Do you
Yes.
understand?
Yes,
Okay,
sir.
okay. If you have understood it, then we will quickly move to the another one. But I need to check the time also because I do not want it to get disrupted. What's the time expiry? Let me check. Okay, so we have some 15 minutes more and we can just finish it up to that time. Okay, now another relation is like the second one is again very simple. You have to find that d by dx of x raised to power minus n jn of x, jn of x is equal to minus x raised to power n j raise it by 1 jn plus 1 of x. We have to prove. Again, the proof is very similar, but there is some little bit a different thing that I will show you. Okay, so again I will show that since this Jn of x is equal to summation r running from 0 to infinity minus 1 raised to power r into 1 divided by r factorial gamma of n plus r plus 1 x by 2 raised to power n plus 2r. Okay, we already know this. Now you have to write it so many times that you will remember it all through your life. Bessel function. Okay, again, so what I will do, I will just take the derivative d by dx of x raised to power minus n. I have 10 minutes warning. Okay, d by dx of x raised to power minus n j n of x. So what I do, I just multiply it by x raised minus x raised power x raised power minus n, then I will take the derivative. So I will do that in the one step. I will write down this as d by dx of summation where r is running from 0 to infinity minus 1 raised to power r. Very good. Okay, when you will multiply it x raised power minus n, it will be simply x raised power twice r, isn't it? X raised power n and x raised power minus will go out. Divided by r factorial into gamma of n plus r plus 1, okay, into 2 raised to power n plus 2r. So this is the thing. Now I have to take the derivative of it. Okay, so what I will do, so taking the derivative, you will simply write this as summation. This is minus 1 raised to power r. Its derivative is simply twice r into x raised to power 2r minus 1, shall I, divided by r factorial into gamma of n plus r plus 1 into 2 raised to power n plus 2r. Okay, very good. Now this is x raised to power 2r minus 1, 2r. This 2 will go into the denominator. This r factorial is always given by n factorial. R factorial is given by r into r minus 1 factorial. Isn't it?
Yes,
5
sir.
factorial is given always given by 5 into 5 minus 1 factorial. That is 5 into 4 factorial. That is 5 factorial. Right? So like n factorial is given by this. So okay, this r factorial is given by r into r minus 1 factorial. So one r will get cancelled out with this. You can simply write this as summation minus 1 raised to power r x raised to power 2r minus 1, and in the denominator we simply have r minus 1 factorial because r will get cancelled out with this r, and we have gamma of n plus r plus 1. This is will be twice n plus 2r, और ये 2 जो यहाँ पे है, this will go into the denominator, it will be 2r minus 1. Okay, up to this point it was very similar to your previous case, but I will make some assumption here. I will just suppose that let this r minus 1 is equal to k. So I'm assuming that let r minus 1 is equal to k implies this r is equal to then k plus 1. So what will this particular equation become? So this will become right hand side. I'm going to write only the right hand side. You will simply write this as summation r running from 0 to infinity minus 1 raised to power r is shabash k plus 1. R is k plus 1. It will be x raised to power. This will be 2k plus 1. That is 2k plus 2 minus 1. That is 2k plus 1 divided by r minus 1. R minus 1 is k factorial. K. So this will become k factorial, Shavash, into gamma of r is k plus 1. So it will become n plus k plus 2.
Two.
N plus k plus 2. Okay. Into 2 raised to power n is, sorry, this r is k plus
Plus
1.
one.
So this will become n
K.
plus 2k plus 1. N plus 2k plus 1. Right? Okay. Or I can just add and subtract this x raised power minus 1. I will just write down this. I will simply write it here. It is, I can just write it x raised power minus n summation r running from 0 to infinity. Okay. Rather, we can take this k running from 0 to infinity. Okay. Forget about it. Okay. Minus 1 raised to power k plus 1. Right. But I will write down minus 1 raised to power minus 1. That is minus 1 raised to power k plus 1, minus 1 raised to power 1, that is minus. So that minus I am writing it here, minus. So minus 1 raised to power k, okay, x raised to power n plus 2k plus 1 n plus 2k plus 1 divided by 2 raised to power n plus 2k plus 1 into k factorial gamma of n plus k plus 2. I hope you are getting it. x raised power n को मैं multiply यहाँ पे कर रहा हूँ. X raised power, sorry, this is, yes, x raised power n, because when you will multiply with this will be x raised power 0, this is 1, so you will get simply x raised power 2k plus 1. ठीक है? So now you know that, so this thing I can write down it here, so you will say that ये वाली जो equation है यहाँ से मैं, this equation I am repeating it, you write down this as this will be equal to minus x raised power n. Okay, I will write down this as j, yeah, I will just first write this as summation minus 1 raised to power k, okay, 1 divided by k factorial into gamma of n plus 2 n plus k plus 2 into x by 2 raised to power n plus 2k plus 1, n plus 2k plus 1. We can write down this as this is minus x raised power n j in n plus 1 of x. Or I can write down say jk plus 1 of x, and I can just write, sorry, n plus 1 of x. So this is what was d by dx of x raised power minus n into jn of x. So see, now how I prove that? Suppose we have a Bessel function of this. Suppose n is equal to n plus 1. What is jn plus 1 of x from this equation? So you will simply write this as minus 1 raised to power r 1 divided by r factorial gamma of n plus r plus 2 into x by 2 raised to power n plus 2r plus 1. So this is now 2k plus 1. So that's why I write down this as j of n plus 1. So we are raising this integer by plus 1. So instead of writing it, I just simply write it as jn of x. Now I'm going to show you how we can plot this j1x, j0x, j half, j2. But it will take some time. I will just show you it in the next lecture. So again, let it you just join again for some minutes, some 10-15 minutes, because I have one or two. It will take only 10-15 minutes, then you can go. I just want to, if you have any question to ask, you can ask, or if there is some point where you do find it difficult to understand, just let me know, so that I will just, I didn't rub it, I just rub it so that I can share it. I can move to that. I can move.
Right side.
Sorry. Sorry, बोलो.
स्टेप देखो ना राइट साइड कॉर्नर में, लास्ट देखो ना राइट साइड कॉर्नर में सेटअप बन साइड.
यस, ये कहाँ पे? यहाँ पे ये this
yes sir.
Okay,
Yes,
see what I did. Okay, I just multiply this is it okay? Is this equation okay? I just multiply x raised power minus n into x raised power n. इसको मैंने ये multiply किया है. मैंने इसको ये चीज multiply किया है because you know that this will be x raised power 0, that is 1. So it doesn't make much difference, but I can write down this I am doing. So what I am doing here, I am taking 1 x raised power minus n because I am having a look at what I actually have to obtain. मुझे ये obtain करना है. That's why I take 1 x raised power minus n. Then I just trying to make it into a more general form. जो already हमारे पास the Bessel functions of first kind है, जो हमारे this Bessel function है. I simply multiply 8 by, so this is again like I just multiply, divide and this ना multiply and divide by x raised power n. अगर मैं इस चीज को x raised power n और x raised power n, so I can write down this as x raised power n into x raised power minus n. That is one and the same चीज थी. आप इससे भी बोल सकते हो. तो यहाँ पे simply मैंने multiply and divide by x raised power minus n, x raised power minus n किया है. Is it okay now? बाकी सारी चीजें मैंने सही सेम लिखी है, खाली फिर मैंने ये यहाँ पे x रेज़ पावर माइनस n टर्म यहाँ पे एक्स्ट्रा की है, और यहाँ पे जब इसको एक x रेज़ पावर n से करोगे इट विल बी x रेज़ पावर n प्लस 2k प्लस 1. सो मैंने वही चीज यहाँ पे लिख दी है. इज इट ओके?
Yes, okay.
Multiply and divide by x raised power n से मैंने किया है. Okay, again quickly I'm just only just 10-15 minutes it will take more, then after that you can leave. So let us join for another class.